how we can prevent these attacks? As you can see, the victim is not doing anything sometimes. It is just the browser via cross-site scripting executing the attack. How come we as an end users can protect about this? Okay, there are two things. First, obviously avoid cross-site scripting by following all the recommendations that we talk about in our cross-site scripting course. Because if we don't avoid it, the attacker can always do this on behalf of our browser without our knowledge. That's the first thing. Also, the token, if we implement a token, which we're going to see, the cross-site scripting can steal those tokens and do any of the malicious operations. When we talk about the tokens is this. We recommend a synchronizer token pattern. What that means? We generate, as developers, random tokens generated per user's session. So we connect to Netflix, we send back a token to that specific user, and that token is going to be included in every single request sent by that specific user. So we connect to Netflix, we get a token, and every time we want to do a transaction in that session, we need to send back the token all the time. As you can see, that token is generated just at that specific moment for that specific user in all the different links. That helps us to validate the request being made by that specific user. Should not be guessable by the attacker, of course, because then they can predict and send the same tokens. Should be expired and only valid for that current session. So this is an example of a token. So basically, when you connect to Netflix, let's say in this example, we get back that specific token that every time we want to do another operation in that specific session, we need to send back that token. What that means, let's see the example now with the token implemented. When this person connect, let's say to PayPal in this case, they connect, PayPal send back a token to this user. So the next time the user wants to interact with PayPal, they send, as you can see there, the token. Okay? So PayPal replies with the same token, the session. But what happens is suddenly the attacker tries to do the cross-site request forgery attack. The attacker is going to be able to send the session if they want, but they don't know the token. As you remember, that token was downloaded for that specific browser in all the links. But the attacker is in a different machine. They don't know about that specific token because they were not authenticated. So when they send the request to make a payment, they get a payment denied because there is no token found. That's the reason that a token must be implemented with all the features that we just discussed in order to prevent this kind of attack and validate that the user is not doing that specific operation. Here are some references for cross-site request forgery for you guys to follow. And finally, we have the summary. See, a cross-site request forgery doesn't need cross-site scripting to be successful. Keep in mind that we can force the end user to click on a link, load an image, and game over. We don't need any other vulnerability to exploit it. The victim normally is not aware of this, as you know. And the random token design is key for the successful protection. If we generate a token unique, expired at a certain period of time for that specific session, not guessable, we're going to be able to protect our applications.